So topic 3 we did, topic 4 as well. The moles, electricity, chemical energetic, topic 6. So reactions in terms of energy change, a reaction can be an endothermic reaction or it can be an exothermic reaction. Exothermic, in which the energy is transferred to the surrounding, so the surrounding temperature increases. And some examples of exothermic reaction: combustion, when you're burning a substance; oxidation, oxidation means when oxygen is added or oxygen is one of the reactant; and neutralization, when acid react with an alkali or acid react with base. An endothermic, the one which absorb energy, surrounding temperature decreases. And endothermic reactions like dissolving and thermal decomposition are endothermic reactions. In terms of bonds, if we want to break the bond, we have to supply energy. Like there's a hydrogen-hydrogen bond. I have to supply energy to break this bond. That's why we call bond breaking is an endothermic change. And bond forming, like if two hydrogen atoms are there, the two atoms will try to form a bond, come close to each other. They release energy. So if energy is released, the reaction will be exothermic. So whenever a chemical reaction occurs, there are some bonds which breaks and some new bonds are formed. But how we work out, we have to check which energy is more. If energy needed to break the bond is greater than energy release, then the reaction will be, overall reaction will be endo. But if energy needed or energy release when, or energy needed to break the bond is less than the energy release, then the reaction will be exo. So overall bond energy change during a chemical reaction is bond breaking minus bond forming. And when you're solving a question related to bond breaking and bond forming, you should first draw the structure of both reactants and product and work out the number of the bonds. It's not about number of the atom, it's about number of the bonds. Like when I say H2, H2 does not means two bonds. H2 means two hydrogen atoms. You have to check how many bonds are there. So if there's only a single bond. Then the energy level diagram for endothermic and exothermic reactions. In terms of the energy level diagram shows the energy of the particles. So when you draw an energy level diagram for reactant and product, in terms of energy of particles, first one is in terms of bonds, the second one is in terms of energy of the particle. So in endothermic reactions, reactant have low energy and the product is having high energy. The difference between them, it's called energy change, which will always be positive. But exothermic reactions, reactant have high energy and the product is having low energy, and the difference in the energy between the reactant and the product, that is always negative. So bond forming are always the exothermic reaction, reactant have high energy and the product having low energy. And endothermic, if reaction is overall endothermic, it will be opposite. Then energy is released when we burn the fuel. Example, combustion of fossil fuel such as coal, natural gas. Whenever we burn, oxidation or combustion reaction take place and it releases energy. Use of the hydrogen as a fuel. Where we use hydrogen as a fuel? We use hydrogen as a fuel in a fuel cell. So what happened in a fuel cell? In a fuel cell, basically hydrogen reacted with oxygen. When something is used as a fuel, the reaction must be an exothermic reaction. So it releases heat energy. The oxidize means reacted with oxygen with the fuel to produce a potential difference or voltage. An overall reaction of hydrogen fuel cell involve an oxidation of hydrogen to produce water. And the fuel cell involves the reaction of a fuel in which hydrogen with oxygen will produce electricity. You can refer this as a combustion, but practically it's like an oxidation rather than combustion, because what happened in a fuel cell, that example, if this is a fuel cell, you don't have to learn the working of a fuel cell. Only the thing which you should know, that the overall reaction of the fuel cell, and this can be used as a source of energy to produce energy. But normally how a fuel cell works, so this is not related to exam point of view, this is just an additional information. When hydrogen is added, this is called a proton exchange membrane. Proton exchange membrane means it can allow only protons to pass through. So when hydrogen enter the fuel cell, this membrane causes a hydrogen molecule to break into hydrogen ion. So hydrogen molecule break into hydrogen ion by loss of two electrons. So electrons cannot travel through this membrane, only protons can travel. So hydrogen molecule dissociate or break down into hydrogen ion, and the electron travel in the external circuit. When electron travel in the external circuit, the lamp will light up, or you can use any electrical appliance here or device to produce, to run or use this energy. And oxygen from here, electrons from this side, and hydrogen, when they recombine together, what it will do produce, it will produce water. So this is actual working of a fuel cell, but you don't have to learn this whole working. The thing which you have to learn, that hydrogen that reacted with oxygen and it produced water molecules. That is the thing which you have to learn. But this is in practical what happened in the fuel cell. Describe radioactive isotopes such as uranium as a source of energy. So uranium, which is a radioactive element, unstable, what we can do, we can target this uranium by a neutron, which is which will undergo a nuclear fission reaction. In nuclear fission, the heavy nucleus break down into a lighter one by removing three more neutrons, and this will be multiplied. So fission reaction is a chain reaction. It is used in power station to produce energy. But there's a problem with these nuclear power station, that it produces a waste which is also radioactive. So there's a problem in disposing of the waste for this type of power station. Is it clear? The endothermic and exothermic reaction. Cell we already discussed. And you can see the energy diagram. Energy profile diagram shows the particle energy. So activation energy from reactant to the point where the reaction start, and the difference in the energy of reactant product is called enthalpy change. Activation energy and the difference in energy is called enthalpy change.